Hello children, I once again welcome you all to online tutoring class for class 9 science. So this is my 5th class with you all, and so far we have covered 2 chapters, that is chapter 9 and 10. So today we will start with a new chapter, that is chapter 11. I want you all to turn your textbook to page number 157. So in the last 3 chapters, that is physics chapter 8, 9, 10, we have talked about different ways of describing the motion, and we have also talked about the causes of motion, why motion takes place, and we have also talked about it is because of the external force that causes motion. And in last class we have talked about gravitation, that it is because of the gravitational force of the earth that pulls the object towards itself. Now in this class, this chapter we are going to discuss on a very common phenomenon like walking, or like walking, running, sitting, standing, and also writing and reading and writing, all this natural phenomena. So when we are going to discuss about reading, writing, walking, all these things, then you must be wondering what are we going to really discuss this class, right? So actually we are going to learn the concept, okay? We are going to learn the concept behind all this reading, writing, or walking, running, sitting, and all standing, all this behind all this natural phenomena. There is a concept, and we are going to discuss about that very concept, and we call it as an work. All right, so this chapter we are going to discuss about the natural phenomenon, that is work. And when we talk about work, then we will also talk about energy also. Why? Because energy, work and energy are very closely related with each other. When I say very closely related with each other, that means later on when we go on with our lessons, you will get to know it better. But then why they are closely related with each other is because, see, in order to do some work, all of us, in order to perform some work or in order to do some work, we all require energy, right? Without energy, we cannot do any work. And that is why we can say that work and energy are very closely related with each other. So today's topic is work and energy. So let us first start with work. If I ask you what is work, then what will be your answer? So in general conversation, generally we can define, or we can say work is nothing but everything that involve physical or mental activities, we call it as work, right? Generally we describe work as everything and anything that involve mental and physical activity, we call it as work. For example, you are going to write your exam, so you are sitting in your table and then you are preparing for your exam, okay? So you are continuously reading, you are continuously writing, or you are continuously practicing. That means if it's for math and science, that means you need a lot of practice, right? So you are continuously reading, writing, and practicing. So after studying for so many hours, you will feel exhausted, right? You will feel exhausted, you will feel tired. So at that point of time, you will say that, oh, I have done so much work today. That means you have used your mental work. That means here I'm talking about not physical work, but then mental work, okay? So you will say that I have done a lot of work today. That is, I have done a lot of mental work. And not only that, but say when you are at home, the cooking or sweeping or mopping or washing, all these activities that we do daily, we call it as work, right? But then science has a definite meaning, and science have a different meaning about work. So in this chapter we are going to learn what is what is work according to science. That means we are going to learn the scientific definition or scientific meaning of work, or how do we measure work, how can we measure work by a person. So according to science, work can be defined as, we can define work as when application of a force according to science, work can be defined as when application of force causes displacement. That means by now I am sure all of you are aware of the term force and displacement, right? Since we have been discussing since chapter 8, from chapter 8 and 9 we have been discussing about force and displacement, so I'm sure you are all aware of the term force and displacement. That means when application of forces causes displacement means a work is said to be done when you apply a force on some object and that object moves from its position, changes its position through the direction of an object, then we can say that the work is done. Say you are applying a force on some object, and due to the application of your force, the objects get displaced. That means you are applying a force, right, on some object, and due to the application of the force that you have applied, it causes displacement. Displacement means position is changing, right? Due to the application of the force that you have applied, it causes displacement. Only then we can say that a work is done. For example, a ball is lying on a table, right? So a ball is lying on a table, so you apply some force with your hand and then you you push the ball, and then on application of the force applied by your hand, the ball will start moving, right? The ball will start moving, and then the ball falls down from the table to the ground. That means here in this case, you have applied some force or not? You have applied some force with your hand, and because of the application of the force that you have applied by your hand, it causes displacement of the object. It causes displacement means the position of the ball has changed, has displaced or changed from table to ground. So here in this case we can say that a work is done, okay, according to science. Again, another example let me give you. For example, there is a very huge big rock, and then you want to move this big rock to another side, and then so you are pushing the rock, okay. You are pushing the rock, but then the rock is not moving. That huge big rock is not moving. So in spite of all your efforts, in spite of all your hard work and all your energy, that means after some time you will feel very exhausted, all your energy is gone, but still then the rock is not moving. That means here in this case, what do you think? Work is done or not? According to science, work is not done, right? You have applied the force. Of course, you have applied the force on the rock, but then displacement is not taking place here in this case, right? That means the rock is not moving from the position to another position. That means displacement is not taken in this case. So in this case, we can say that the work is not done. Again, let me give you another one simple example. Say there is a big building and you are in the ground floor. So you climb up the staircase to reach the top floor, just to view the landscape. Just to view the landscape from the terrace, you climb up the staircase and reach the top floor just to view the landscape. So what do you think? In this case, whether work is done or not, according to science, okay? According to science, whether the work is done or not. Here in this case, work is done. Why? Because you have applied some force on your body, right? You have applied some force, and then because of the application of that force applied by you, your body has displaced. The position of your body has changed from ground floor to the top floor. That means displacement have taken place, application of force also there, and then displacement of an object, displacement of your body has also taken place from ground floor to the top floor. So here in this case, in this example also, we can say that a work is done. So according to science, work done means when an application of force causes displacement. That means work is said to be done when a force is applied on an object, and work is said to be done when some force is applied on the body, and the body moves in the direction the body moves in some distance in the direction of the force. Only then we can say that work is done. And now work is denoted by the letter WD, or just we can write W, okay? And mathematically we can write work done as, we are here, see from the definition itself, when application of force. So force causes displacement. So force into displacement. So displacement we write as. Displacement is denoted by the letter S. So work done is equal to F into S. F means force and then S is displacement. So this is the formula of work done. And okay, the unit of, again, the unit of work done is joule, or the unit of work done is joule or Newton meter. Why it is Newton meter? Again, the joule here, okay, we can say the unit of work done is joule or Newton meter. Why Newton meter? Is because we already know that the unit of force is what? Unit of force is Newton, right? Unit of force is Newton, and then the unit of displacement is nothing but meter. So the unit of work done is Newton meter, or we can say that the unit of work done is joule. And this, the name joule was given in honor of a scientist named James Joule. And the next topic is energy. So the next topic is energy. As I have said, when we talk about work, we will also be discussing about energy, as both energy and work are very closely related with each other. We cannot do any work without energy. If no energy, means we cannot perform or we cannot do any work. So that means energy and work are very closely related with each other. And again, the word energy is a very common word, right, that we hear it every day. And so, but again, science has given a definite and precise meaning about energy. So even here we are going to talk about energy according to science. But before that, let me give you an example, okay? So you want to put a nail on a wood. So in order to put a nail on a wood, what you will do? You will raise a hammer, right? You will raise a hammer and then hit the nail. Only then the nail will go inside the wood. That means when you raise your hand, you are doing some work on the hammer, right? And when you raise your hand, you are doing some work, and then in order to raise your hand, if there is no energy, then will you be able to raise your hand? No, right? In order to raise the hand also you need energy. And so in order to do some work, we need energy, and because of that energy we are able to perform a work. So even same case, in order to raise a hammer, you need an energy. Another example, say a toy car. Okay, a toy car with a key. So in order to let the toy car move, what you will do? You will wind the key, right? You will wind the key means while winding the key, you are doing some work. In order to do that work, in order to do the work, the winding of the key, you need energy. Yes, you need energy. Without energy, you will not be able to wind the key also. That means in order to wind the key also you need energy, and because of that energy you are able to do work. And after you release it, because of the energy that is in the because of the energy and because of the work that you have performed by your hand, the toy car will start moving after you release the key. So from both these examples we understand that in order to do any work, or in order to perform any work, we need energy. And the object having a capability to do work, is to possess an energy. And also we can also say that energy is the strength. Okay, energy is the strength that is required to do a sustained work. In order to do some work, we all need strength, right? We all need strength, and that strength that we need is nothing but we call it as energy. For example, say you are doing some heavy work, okay? You are doing some heavy work, and after working for so many hours, you feel tired, you feel exhausted, right? Why you feel tired or why you feel exhausted is because something is lost from your body, and because of that you are feeling tired or you are feeling exhausted, and that's something which you have lost from your body is nothing but we call it as energy, okay? So in science, energy can be defined as the ability or the capacity to do work. Ability or the ability or the capacity to do work, we call it as energy. And the unit of energy is again joule, and this energy is a scalar quantity. From the motion chapter you have already learned what is scalar and then what is vector quantity. Scalar means only magnitude, we don't need direction. So energy is a scalar quantity, and again there are different forms of energy, okay? There are different forms of energy like mechanical energy, chemical energy, heat energy, light energy, okay? So there are different forms of energy, but in this chapter we are going to discuss, or we are going to focus on only one form of energy, that is mechanical energy. So what is mechanical energy? Mechanical energy is the energy that is used to move a body to change its position. That means energy in motion. Energy in motion, we call it as, motion means movement, right? So energy in motion, we call it as a mechanical energy. Again, mechanical energy is further divided into two types, that is kinetic energy and potential energy. So again, mechanical energy is further divided into two types, that is kinetic energy and potential energy. We will discuss them one by one. So the first is what is kinetic energy? Kinetic energy is nothing but the energy by virtue of motion. Virtue of motion, that means we can also say that energy possessed by a body due to its motion, we call it as a kinetic energy. I repeat again, energy possessed by a body due to its motion, we call it as a kinetic energy. That means I want you all to remember that the word kinetic means something which is moving, okay? Something which is in motion or which is moving, we call it as a kinetic energy. So kinetic means what? Motion. Always remember this. Something which is in motion or which is moving, we call it as kinetic energy. Let me give you one very simple example. Like when we walk, we are moving, yes or no? Right? When we walk, we are moving. That means our position is changing from one place to another place with time. And whenever anything that is in motion, we call it as energy. We are able to move, we are able to work because of the energy possessed by our body, right? And that energy possessed by our body, we call it as a kinetic energy. So remember that anything which is in motion, we call it as something which is in motion or moving, we call it as a kinetic energy. Let me give you some examples, like a moving car or anything that is in motion. So the moving car, flowing water also is an example of kinetic energy, or the moving wind. Yes, the moving wind is also another example of kinetic energy. So all these examples, like we walking, moving car, or flowing water, whatever example I have given, or the moving wind are all some of the moving object that is performing some work. So again, the question here is, how are these objects, say, as I have said, we walk, right? We walk, that means we are moving. How are all these objects, that whether it is human being or whether it is animals, or say I have given you example about moving car. So how all this object, moving car or water, flowing water, or this air, how they are managing to do this work, how they are able to do this work, or how the movement is taking place. How? It is because of the energy possessed by their body, by the respective body. It is because of that one energy possessed by their body, they are able to move from one place to another place, right? And that energy possessed by their body, we call it as kinetic energy. So kinetic energy is denoted by letter Ke, and the unit is again joule. Okay, the unit of kinetic energy is joule, and whenever an object have mass m, moving with a velocity of v, then we can say that the body possesses a kinetic energy. And the kinetic mathematically, kinetic energy can be written as Ke is equal to half mv square. Now, from where we are getting this half mv square? How do we know that the kinetic energy is half mv square? Let us find out. Okay, let us find out. Since kinetic energy is equal to half mv square, let us find out the expression for this kinetic energy, that is half mv square. Say, for example, let us assume we have an object, and that object is ball. Okay, we have one object, that is ball, and this object have mass m. Okay, this object have mass m. So initially the ball was at rest. That means the ball was not moving. So initially the ball was moving. So initially the ball was moving with a velocity of, initial velocity will be u. So say the ball has mass m. Okay, initially the ball was moving with a velocity u. So this is the initial velocity. So the ball was moving with initially the ball was moving with a velocity v, but after you apply some force, okay, after you apply some force on the ball, the velocity will increase. So the velocity will change from initial velocity, that is u. The velocity has changed from u to v. Okay, the velocity has changed from u to v. Now let us find out the work done. What is the work done? We already know that work done is nothing but force into displacement. That is F into, S, right? We know that force is nothing but, work done is nothing but force into displacement. So initially the ball was moving with a velocity u, and after some time I apply some force, and after applying some force, the velocity changes from, the velocity increases. That means the velocity increases from u to v. That means the change in velocity means acceleration is taking place, right? Velocity is increasing means acceleration is taking place. So here in this case, let us assume the acceleration due to the change in velocity is nothing but a. Okay, that means acceleration. Acceleration is, let us assume the acceleration due to the change in velocity is a. Now here we have got a, acceleration we have got a, we have initial velocity, we have final velocity, and we have displacement here. So let us see, we have in chapter 8 we have discussed about, we have learned about the three equations of motion. That is first equation of motion, second equation of motion, and then third equation of motion. So let us see the relation, connecting this acceleration. Let us see the relation connecting the acceleration, initial velocity, final velocity, and then displacement. So the relation connecting all these four is nothing but the third equation of motion. So from third equation of motion, what is the third equation? What is the formula of third equation of motion? The third equation of motion is nothing but v square is equal to u square plus 2as. Initial velocity, final velocity is equal to initial velocity square plus 2 into acceleration into displacement. So this is the third equation of motion. Since we are going to find out this, okay, work done. Let us say this is equation 1. Let us keep this as equation 1. Let us say this is equation 1, that is work done is equal to force into displacement is equation 1. So since we are going to find out the work done, that is F and S, let us bring this S to one side and the remaining to other side. So if we bring this S to one side, then it will become V square minus U square divided by 2A, right? Let's make this as equation 2. So this is equation 2. We have got S here. We have got the value of S. Now let us find out what is F. So again from Newton's second law. From Newton's second law we know that F is equal to what? F is nothing but it is the product of mass into acceleration, right? Mass into acceleration. So let's make this as equation 3. So let us put the value of this equation 2 and then equation 3 in equation 1. So putting the value of equation 2 and 3 in equation 1, what we will get? What is equation 1? So work done is equal to force into displacement. This is the equation 1. So we are going to put the value of F and S here. So what is the value of S from equation 2? Value of S is V square minus U square divided by, what is the value of F is, the value of F is mass into acceleration, right? And the value of S from equation 2 we have, value of S is V square minus U square divided by 2A. So AA means we cancel this AA. The remaining is M into V square minus U square divided by 2. So now we can write like this. 1 by 2 into V square minus U square, right? And as I have said that initially the ball was moving with a velocity u, right? So initially the ball was, let us assume again that initially the ball was at rest. When I say at rest means the ball was not moving. That means the velocity is 0, right? So the initial velocity is 0. That is u, this is u, okay. So initial velocity is 0. So let us again put the value of this initial velocity, that is u is equal to 0 in this equation. Okay, if we put the value of this 0 in this equation, then we will get m is equal to v square minus 0. 0 to the power 2 means it is 0 only. So from here we get half mv square, right? So this is the expression for this kinetic energy, and this is the formula, or we can also say that this is the formula of kinetic energy. That is, kinetic energy is equal to half mv square. So I hope you are all clear with this. Always remember that kinetic energy means something which is in motion, okay? Movement. When movement is taking place, that means it is because of the kinetic energy. Now let us see what is potential energy. The second The second types of mechanical energy is potential energy, right? So let us see what is potential energy. Potential energy is nothing but the stored energy. We call it as potential energy. So when I say stored energy means what? What is stored energy? That means the energy stored in the body, okay? The energy stored in the body which is utilized by an object in the future action, we call it as energy, potential energy. So let me give you again another example. So all of us, we do so many activities every day, right? So we do so many, some of us, we do, we work, we do some exercise, we play games. So every day we do so many activities. So in order to do all these activities, we need energy, right? So where do you think you are getting those energy from? So the energy that, the activities that you are performing every day is because of an energy. That means it is because of the energy that is stored in your body, and because of that you are able to do some work, or you are able to do so many activities. So from where do you think that you are getting those energy from? Those energy that is stored in your body is from when we sleep, okay? When we sleep, that means we are storing energy. When we sleep, we are storing energy in our body, or we are preserving energy. And why we are preserving energy, or why you are storing energy when we sleep, is because when we woke up from our sleep, we have to convert that stored energy in our body into some action, right? So in order to do some work, during our sleep, we are storing or preserving energy, and when we woke up from our sleep, we are utilizing those stored energy that is inside our body to do so many activities, to do many daily activities. And that energy that is stored during your sleep, or when we sleep, is nothing but we call it as kinetic energy, potential energy. Okay, so we can define potential energy as energy stored by a body due to its position or so potential energy is nothing but the energy stored by a body due to its position or configuration. We call it as potential energy. Okay, before we wind up, we will try to look into more examples in the next class since we are running out of time. But before that, let me give you again another example. Say energy stored, right? The main part is here, energy stored. So the same example I will give you, the toy car with a key, okay? So in order to let the toy car move from one position to another position, you have to wind the key, right? So when you are winding the key, you are actually doing some work. And that work we are doing is getting stored, is getting transferred and getting stored in that object that is a toy car. So you are storing some object in the toy car. The stored energy in the toy car is nothing but we call it as a potential energy. And as soon as you release the key, what will happen? The toy car will start moving, right? That means the toy car is utilizing, okay? The toy car is utilizing those energy that is stored in the car when you are winding the key, when you are working, when you are doing some work on the object. So the toy car is utilizing those stored energy, and those stored energy we call it as a potential energy. That means, as I have said, potential means stored energy and kinetic energy means something which is moving, right? So as soon as you release the key, the car will start moving. That means potential energy is converted into what? Potential energy is converted into kinetic energy here in this case, right? So the stored energy means the potential energy, always remember that, and the kinetic energy means that is anything which is moving, we call it as kinetic energy. So we will stop from here. We have covered almost most of the topic in this. This is a very short chapter, so we have covered almost all of the topic. Only say 2 topics left, so we will continue in the next class. So thank you.